Alright guys, welcome to this page of the notes, and again what we're doing is I am giving you these problems where I give you a polynomial and we're going to use the factor theorem and the rational zeros theorem to work our way the entire way through this problem, not being given anything except the polynomial, to find all of the rational zeros, irrational zeros, and imaginary zeros if there are any. We're looking for all the zeros. My polynomial is a third degree polynomial, so I know when I get done, I'd better have 3 answers. Let's see what happens. First, I need to make my list of possibilities. That requires the rational zeros theorem, which is a naught, which in this case is 4, and a n, which once again is a 1. Remember, I do that because it makes your life a lot easier. Your list of possibilities is just going to be the factors of a naught, because anything divided by 1 is itself. All right, the factors of 4 are plus or minus 1, plus or minus 2, and plus or minus 4, which means a naught over a n is equal to plus or minus 1, plus or minus 2, and plus or minus 4. So here's all of my possibilities. I could have x minus 1, x plus 1, x minus 2, x plus 2, x minus 4, x plus 4. And again, each of these possible factors represents each of these zeros, right? If I were to set this equal to 0 and solve, I get plus 1, plus 1. Set this equal to 0 and solve, I get minus 1, minus 1, right? All the way down through the list, right? So I'm going to check each of these factors. Again, I have not done this problem ahead of time, guys. You're watching live math. We're working through this together. I have no idea which one of these is going to work, if any of them. I'm going to start at the top of the list. I'm going to work my way through until I find one that gives me a remainder of 0. So here we go. Synthetic division. The first one I'm going to do, set this equal to 0 and solve, I get a positive 1. So we're going to throw a 1 in there, goes inside the box. Check to make sure I don't need any placeholders. 3, 2, 1, 0. Everybody's there. I don't need any placeholders. It's going to be a 1, a 2, a negative 2, and a minus 4. All right, here we go. Bring down the 1. 1 times 1 is 1. That's going to give me a 3. That's going to give me a 3, which is going to be a 1. 1 times 1 is 1. That gives me a minus 3. The remainder is minus 3, and that one does not work. On to the next one. Set this guy equal to 0 and solve. You get a negative 1. 1, 2, negative 2, negative 4. Bring down the 1. That's going to be a negative 1. That's going to be a 1. That's going to be a negative 1, which is a minus 3. That's going to be a positive. I get a remainder of negative 1. Not what I'm looking for. That guy doesn't work. On to the next one. X minus 2 equal to 0, which means x is equal to a positive 2. Let me slide up just a little bit. All right, so we're going to do synthetic division with a positive 2. That goes inside the box. Pull out your coefficients. 2, 1, 2, negative 2, negative 4. Here we go. Bring down the 1. 1 times 2 is 2. It's going to be a 4. 2 times 4 is going to be a positive 8, which is going to give me a 6. 2 times 6 is going to be 12. Minus 4 is going to be a positive 8. That doesn't work. Next, set this equal to 0 and solve. I get a negative 2. 1, 2, negative 2, negative 4. Bring down the 1. Okay, that's going to give me a negative 2, which is 0. Interesting. Negative 2 times 0 is 0. That's going to give me a negative. Hey, look at that. We got it. Winner, winner, chicken dinner. We found ourselves our rational 0. It's this guy right here. That's our winner. It gets me a remainder of 0. And so I know that I've now found a factor, which, guys, remember, means you can rewrite that polynomial. This guy right here, this polynomial I gave you, can be rewritten as this factor and the reduced polynomial you get from doing the synthetic division. So here we go. What was my polynomial? All right, f of x. So we'll call it f of x because that's what it was named. Don't change its name. All right, it was an x plus 2 And my reduced polynomial, it was a third degree polynomial, which means my reduced polynomial is now going to be a second degree polynomial. So x squared. That's going to be a 0x, which drops out. You don't need it. 0 times x is just 0. So minus 2. All right, I want you to find the zeros. So we set that puppy equal to 0. 0 product property splits it up. Got to take the square root of both sides. Don't forget to do plus or minus. And boom, there you go, just like that. You guys have solved this problem. I get 3 zeros. -2, plus the square root of 2, and minus the square root of 2. That's my 3 zeros. The fundamental theorem of algebra is satisfied, and you guys should be very proud of yourselves. You just worked through a very, very difficult problem systematically using the rational zeros theorem and the factor theorem of polynomials. Well done, guys. Head on over to the next page of notes. We'll try one more of these together, so I'll meet you over there.